Students, today we are going to study reactions of organic compounds. Up to now we have learned about nomenclature and isomers, and there are several introduction part of organic chemistry. Today is the day we are going to study the introduction of the reactions in organic compounds. When you are talking about organic reactions, there are several types we have to consider. So today we are going to learn there are several types of reactions, and I will explain you using a graphical method. Here the addition reaction. What is an addition reaction? I will explain by using these shapes. Think about this circle is one molecule and triangle and square combining with represent the one molecule and react with those two molecules to form this circle combined with square and triangle. So this type of reaction we call addition. In addition, two square and triangle combine to one molecule. So this is type reaction is we call addition reaction. Next type is substitution. Substitution, this is the way I have to explain you. Substitution means one can substitute by other. So here in the reactant we have circle with triangle. This triangle can leave out and square can fit into that point. That means square substitute by triangle. So therefore this type of reactions we call substitution. And next one is elimination. Elimination means what? Elimination means eliminate, escape something. So therefore this type of reaction, it's the opposite of addition reaction. So then this type of reactions we call elimination. What eliminate from this reactant? The molecule. In the reactant molecule they have square and triangle combined to the circle, and this square and triangle leave out, eliminate to outside by remaining only circle. So this type of reactions we call elimination. And the final type is the condensation. In condensation we have two reactants which contains one circle contained with triangle and other circle contained with square. So then when these two circles combine into one molecule, then this triangle and square making another molecules and leave. So therefore normally in the organic compounds this kind of condensation reactions take place and big molecules. It's like two circles combined together, like big molecules are formed by leaving small molecules such as water molecules, ammonia. That type of reaction can be take place in organic. There are important chemical species involved in organic reactions. They are electrophiles, nucleophiles, and free radicals. Let's study what are those. What is an electrophile? Electrophile is a chemical species that form bonds with nucleophile by accepting an electron pair. So let's study the word electrophile to understand more about electrophiles. Electro means electrons, and phile, it's coming from a Greek word called philos, so that means loving. So that means electrophile, it's loving electrons. So therefore they are try to accept electrons. They are therefore electrophiles are seeking electrons from elsewhere. So therefore they are more like to attack some negatively charged part of any chemicals. And They are Lewis bases, as we know in Lewis structure, as we know which type of compounds are electron accepting compounds. They are for Lewis bases. Therefore, electrophiles always Lewis base, and most of electrophiles are positively charged, or we can say it have an atom that carries a partial positive charge, or we can say it, they have an atoms that does not have an octet of electrons. That is why they want electrons. They are seeking electrons, they like electrons, they are loving electrons, therefore they are trying to find an electrons to stabilize. That type of chemical species we call an electrophile. This is the chemical symbols we are using in future lesson for represent an electrophile. What is nucleophile? Nucleophile is a chemical species that forms bond with electrophile by donating an electron pair. So that means electrophiles accepting electron pairs, and nucleophile is the opposite part which donate electrons. Therefore, let's study this one also. In the name, nucleo means nucleus. That means the central part of atoms which contains protons and neutrons. That means it has positive charge. So therefore, phile, as we know, it's loving, likes. Therefore, nucleophile means they love nucleus. They are finding, they are seeking nucleus. That means they are trying to find out positively charged part of any chemicals. Therefore, nucleophiles are seeking positive charge, and they are Lewis bases, and all molecules and ions with a free pair of electrons or at least one pi bond can act as electrophiles. This is the symbol we can use to represent the nucleophile in future lessons. Now you can understand which type of chemical species we are talking about as a nucleophile. Next important chemical species is called free radical. So let's study what is this. Free radical is an atom, it may be molecule or an ion that has unpaired valence electrons. Unpaired valence electron means single electrons. So meaning of this radical is active, reactive, and some progressive, some revolutionary, that kind of meaning. That means as you know that radical peoples are there. We are calling radical people because they are more attractive to some places, and they are reactive and progressive people. So then free radicals are seeking single electrons. Therefore, another radical or bonds or lone pairs or any place where existence of electrons, they are seeking to catch single electron to stabilize. It's like a single person. They are try to couple. So therefore, most of unpaired electrons makes radicals which has highly chemical reactive component, and many radicals spontaneously dimerize. Why? To stabilize. Then dimerizing two radicals means they are couple this single electron to double. So then most organic radical have short lifetime because they are highly reactive, and or they are going to dimerize to stabilize. Therefore, they have small lifetime. And this is the representative of radicals in our future lessons. Now you know what are the type of chemical species which are involved in organic chemistry and organic reactions. Some special points you should know: the arrows we are using to represent the mechanisms of chemical reactions of organic compounds. So therefore some what represent from these arrows of um, some chemical reactions. So you should know that part before you are going to study about reactions of organic compounds. So half-headed arrow, for example, this, think about A atom, B atom together, we have they have a bond. So then we can draw this single half-headed arrow, means the tail part of this arrow means the electrons from this tail part of this arrow, think about this side from here to here. Here what is that means? B, that means to atom. The movement of this electron, single electrons from bond to this atom, represented by this notation. So therefore if you can draw this kind of two arrows, so then our final product should be this kind of thing. So it means the representing of the half-headed arrow means single electron movement from bond to atom. In here, in this example you have, so therefore this bond break. Why? Because two electrons, one goes to B and one goes to A, therefore two radicals they can form as shown in this example. And the normal headed arrows represent that two electrons moving from one to other place from tail to head. That means in this represent two electrons from this bond moves to B. So then what is the product? Should be B minus and A plus, because A they lost one electron, B gain one more electron. Therefore in this arrow represent two electrons movement from bond to atom. And this double that this normal arrows can represent some movement from bond to bond. Here from here this represent that two electrons from this pi electron can move to between B and C to form another bond, another pi bond between B and C. So then what will happen? New bond form B and C and remove that the bond pi bonds of A between A and B. So then this plus charge can move from C to A. So that kind of can be take place in reaction mechanisms. So that represent, this arrow represent the two electrons movement from bond to adjacent bonds. That is also representing in chemical reactions of organic compounds. So therefore you should know these notations, why we are using these arrows, which represent from these arrows you should know before you are going to talk about chemical reactions of organic compounds. Therefore that is also very important part. So now I think you have a good idea about these arrows. And next, two things we should know: effect on chemical reactions. One is induction effect. What is this induction effect? It's a polarization of sigma bonds. As you know, there are two types of bonds. One is sigma and another one is pi. So therefore, polarization of sigma bonds when an electronegative atom or group withdraws electron pair of sigma bonds toward itself. So that means the induction. So then this polarization is transmitted through sigma bonds by creating a permanent dipole in molecules. We call induction effects. For we can take this example. Think about this kind of chlorine atom is combined with this kind of organic compound. So then this chlorine can, it's a some kind of electronegative atom with compared to carbon. So therefore it can polarize this one. In this example, this polarization from right to left can be take place. So then I will take examples for then here. This negatively charge can be take place because chlorine has high electronegativity, therefore they withdraws their electrons towards them, um, and therefore C plus carbon atom of this just uh, attached to chlorine, because chlorine attract these electrons. So then from organic part they withdraw their electrons to chlorine side. Therefore first carbon has some positive charge, and this effect uh, for second carbon also. Therefore it also has some small positive charge, and again we can say this is some very small effect to the next adjacent carbons. Therefore this kind of carbons, every carbons have some effect due to this attraction of electrons from this chlorine atom due to their electronegativity. Therefore this effect taking place where sigma bonds. So that kind of effects we call induction effects, that is a permanent dipole which produce due to the electronegativity of atoms. So then this induction effects also very important when you are discussing about chemical reactions. Next important effect is called resonance effect. Here the resonance effect describes the polarity produced in a molecule by interaction of pi electrons or electrons in lone pairs. Here the between lone electron pair and a pi bond. We can write down this kind of example. In this example, we can take this electron um, coming from this pi bond to this carbon atom. Therefore it become negatively charged and other carbon become positively charged, and again this negatively charged, so this electron pair can again back into between two carbon atoms to form a pi bond. So therefore this resonance structures, in here this example we have two resonance structures. Due to these two resonance structures, as you can see, one carbon become negatively charged and one become positively charged. Therefore nucleophile can be attached to this carbon, and electrophile can be attached to this carbon due to their charge. Therefore this resonance effect uh, is very important part for the chemical reactions of organic compound. Let's take another example, which interaction of two pi bonds in adjacent atoms. This is the example. In here let's draw the numbers 1, 2 and 3. From at the beginning pi bond is exist from carbon 1 and 2 atoms, then it moves to 3 and 2 carbon atoms. Due to this movement, positive charge jump into first carbon from third carbon atom. Therefore we can say this nucleophile can attach to first and third carbon but not to second carbon. Therefore this resonance effect very important when you are talking about chemical reactions of organic compound. Up to now we learn about some terms and some important effects and those uh, things which are important before you are going to study about some reactions in organic compounds. Now let's study the specific reactions in organic compounds, and I think what you have learned up to now will important to study about the reactions in organic compounds. First one is free radical substitution. Let's take example chlorine molecule. In this chlorine molecule can absorb UV radiations and break into two radicals by taking single electrons to each atom. So this starting point of preparation of radicals we call initiation step. At the initiation part, this kind of molecules can break into radicals. Then these radicals now highly reactive, so therefore this kind of organic molecule, if it meet with these radicals, it can take electrons to neutralize, and therefore these organic compounds also can make another radicals we call CH3 radical and HCl molecule. It can form this kind of process that radicals react with another molecule to form another radical. Therefore, in this kind of steps, reactants also contains radicals and products also contains radical. We call propagation steps. Then these kind of two radicals can be neutralized by making bonds. This type of reactions we call termination step. So therefore, in free radical reactions, we have three steps: initiation, propagation, and termination. These reactions is taking place due to free radicals, and they can form new chemicals. This type of reactions we call free radical substitution. In this example, hydrogen substitute to chlorine. Therefore, this is a free radical substitution. Next type of reactions are called nucleophilic substitution. As you can see in the topic, you can understand these type of reactions involve and initiate by a nucleophile, and it is kind of substitution reaction. Nucleophilic substitutions have two type of reactions. One is SN2, that means substitution of nucleophile 2. This 2 representative the two molecules. Here the example is alkyl halide and a nucleophile. In this alkyl halide, let's consider this X is highly electronegative atom with compared to carbon. Therefore, they can form this kind of negative and positive ends. Therefore, this nucleophile can attach to this carbon which has positive charge. Therefore, these two electrons in CX bond can go towards X side, and then they can form X minus ion by producing the replacing of nucleophile into X. We call this as a substitution of nucleophile 2 type reaction. And next one is SN1, that means substitution of nucleophile 1. Why this is 1? Because this alkyl halide itself can make this leave of this X into X minus ion, and to form intermediate product we call carbocations. This carbocation, now it has positive charge, then this nucleophile can attach to this positive ion, and they can substitute nucleophile into that point. So therefore, this is two type of reaction. SN2, it's like a husband can take new wife, and then his old wife can leave out. And SN1 is type of reaction which husband, then wife already leave husband, and then new wife can bring into the husband in later. So therefore, you have to know the difference between SN2 and SN1. I will take an example of alkyl halide react with alkaline compound. Here OH minus produced by the alkaline medium. Let's think about aqueous hydroxide, aqueous sodium hydroxide react with methylene methyl chloride. Here in this kind of polar compound, it has some negatively and positively charged part of this molecule. Therefore, this OH red OH ions, OH minus ions can attack to this positive charge because this is a nucleophile. OH minus is a nucleophile. Therefore, it can attach to this carbon which has positively charged. Then this bond can break and take every electrons from this bond to chlorine side, and therefore OH replace into Cl. Therefore, alkyl halide convert into alcohol and Cl minus will leave. So this is one example. And next example where the same alkyl halides, but this alkyl halide contains 3 methyl groups around the carbon which attach to chlorine. Therefore, in this kind of compound, this CH3, that means methyl groups, can withdraw electrons due to induction effects. Therefore, it can neutralize this electron attraction to its carbon side, will neutralize the positive charge it can produce. Therefore, this chlorine can leave out by making this kind of positive carbocation, and this can neutralize by induction effect. Therefore, these carbocations are stable. Therefore, this kind of reaction can be take place to this kind of molecule we call tertiary alkyl halide. But this will not take place, for example, of previous methyl chlorides, because it contains hydrogen atoms around the carbon which attach to chlorine. But now CH3 group, that means methyl group, attached to this carbon. Therefore, this can neutralize this plus charge. Therefore, it is stable carbocation. Therefore, this can be take place, and this OH again attached to this one, and they can form this kind of tertiary alcohols. In the first part and the second examples, as we know, the intermediate product which forms during the SN1 reactions we call carbocations. Now let's study their stability according to the involvement of methyl group. Let's consider these 4 carbocations. In these 4 carbocations, right hand side carbocations have more methyl groups, but the left hand side carbocation has less methyl groups. It's no methyl group, only hydrogen. So then induction effect of this methyl group which withdraw their electrons to central carbon atom which has positive charge can neutralize this charge. Therefore, higher stability can be observed. Therefore, the stability increase into this order. This right hand side carbocation has more stability due to the inductive effect. And let's consider this type of carbocations. You can learn more about this type of ions in when you are considering benzene. So this type of carbocations has more resonance structures. They can form with the pi electrons in the benzene ring. Therefore, this has high stability of this carbocation due to the resonance effect. Next type of reactions are nucleophilic addition reaction. This is the example. This is the common mechanism. This kind of nucleophile can attach to this carbon, and oxygen can take electrons from this pi bond, and oxygen become negatively charged, and nucleophile can attach to this carbon. So this kind of reactions we call nucleophilic addition reaction. Why? That is not as previous type of reaction. In the previous type of reaction, they substitute to one atom by nucleophile, but here nucleophile attach, but not any atom or part leave. That means nucleophile and the compound attached together, we call therefore addition reaction. Due to the nucleophile, therefore we call nucleophilic addition reaction. This is one example where cyanide react with ketones and to form alcohol, cyanoalcohols. So this is example. We can learn more about this kind of examples in future lessons. Next type of reactions are elimination reactions. For elimination reaction, I will take this example which contains alkyl halide. In this kind of alkyl halide, as you know, when you mix with polar solvent, they have some negative part and positive part we call permanent dipole. They have due to the electronegativity difference between chlorine and other part. However, if you use non-polar solvent to this one, due to the polar solvent, they have some dipole. However, due to non-polar solvent, if you add, this dipole will be cancelled and they don't show some polarity here. And however, due to the induction effect, this chlorine can attract electrons via sigma bonds. Therefore, this attraction of electrons to a chlorine atom, this hydrogen, the next to this chlorine carbon attached hydrogen atom will be positively charged. Therefore, they have some delta plus charge. Due to this positive charge, any basic solution, or let's think about NaOH dissolved in alcohol medium. Here the medium is some kind of polarity is low and this contains OH minus ions. Therefore, this can take this hydrogen atom and these 2 electrons from this carbon hydrogen bond can goes to carbon atom. Then they have negative charge of carbon atom and water molecule can be produced. Therefore, this electron pair in carbon atom can go to between 2 carbon atoms and this chlorine can leave out to form a double bond. In this example, what happened? The elimination is take place. What is the eliminated compound? Hydrogen atom leave and chlorine leave to form double bond. Therefore, we call this type of reactions is elimination reactions. Next type of reaction, let's talk about electrophilic addition. Here it involves electrophiles and some addition reaction. This is the example of the some kind of opposite of elimination reaction. This double bond contains pi electrons. So then this pi electrons can move to electrophile because electrophiles are seeking electrons. Therefore, they can take electrons from this pi bond. And what will happen? This electrophile can attach to one carbon of these 2 carbon atoms. Then what will happen? This plus charge of electrophile moves to one carbon atom. This is the example. H plus and HCl. If you add HCl to ethylene compound, these pi electrons can take by H plus and they can form this kind of carbocations. Then this chlorine ion can join with this carbon atom to form again alkyl halides. This is we call electrophile. What is the addition part is HCl add into this ethylene, we call addition of electrophile. This reaction start due to electrophile and addition take place. Therefore, we call this type of reactions called electrophilic addition reaction. Next type is electrophilic substitution reaction. This is the example in the similar example. Here, however, I put Y. Y means some kind of uh, group. Let's think about Y is some groups attached to this kind of double bond directly. Then what happened? These pi electrons can move to electrophile, and this electrophile can attach with this carbon atom. Then what will happen is this electron between carbon and Y, this bond moves to two carbon atoms to form double bond, and Y can leave as Y plus. So what will happen? E plus came and Y plus leave. So therefore substitute E into Y. E plus is an electrophile, substitute to Y. Therefore this kind of reactions we call electrophilic substitution. This is the example of electrophilic substitution. Chlorine with anhydrous AlCl3 forms Cl plus electrophiles. Therefore, it can replace one hydrogen of benzene molecule to chlorine. This is the aryl halide you can form by reaction with chlorine anhydrous AlCl3 with benzene. You can form aryl halides. What happened is hydrogen replaced in chlorine. This is type of reactions also a electrophilic substitution reaction. Next type of reactions we call condensation reaction. In condensation reaction, I will take two examples. One is carboxylic acid react with alcohol, and this reaction, I will take in this reaction this OH and this one hydrogen can leave out by forming bonds between this O and this carbon. Then you can form this kind of ester by leaving water molecules. So then we call this is a condensation reaction. We call special reaction, we call esterification. By mixing carboxylic acid and alcohol and leaving water, ester molecule can form. It's a type of condensation reaction. And carboxylic acid and amine react together to form amide by leaving water molecule is another example of condensation reaction. Then in this reaction also water molecule can make by taking this hydrogen from amine and OH from carboxylic acid by forming amide and water molecules. Hydrolysis is also an important type of reactions in organic compounds. When an organic compound mix with water molecule, and we can produce a product with participating H and OH groups combined to this organic compounds, we call that type of reaction as hydrolysis. Hydrolysis of ester is one example for this type of reactions, and ester bond can break through this carbon oxygen bond, and OH group can attach to this carbon and H can attach to this oxygen, and they can form carboxylic acid and alcohol. And similarly, amide can hydrolysis through this carbon nitrogen bond, and they can form carboxylic acid and amide. These are the examples of hydrolysis. So there are several type of hydrolysis reactions in organic chemistry. So we can learn those reactions in next lessons. Oxidation is also an important type of reaction even in the organic chemistry. When you're talking about oxidation, let's remind the oxidation number of an organic compound. This example, let's count the oxidation number. As we know, when one atom combine with another atom which has higher electronegativity, we count as plus 1. If it is a low electronegativity, then we count as minus 1, and the same electronegativity we count as 0. So in this central carbon combine with 4 atoms around that carbon atom. So then for hydrogen, low electronegativity with compared to carbon, therefore we count minus 1, and for oxygen plus 1, and for carbon 0, because the electronegativity same. So then the total oxidation number of this carbon is minus 1 with the summation of all these numbers. According to this kind of oxidation value in organic compounds, let's count first alcohol. Here when count the oxidation number of this carbon, we know that minus 1, and let's count for this carbon, it is plus 1. Why it's plus 1? Because carbon carbon bond 0 count, carbon hydrogen minus 1, but there are two bonds combined with oxygen, therefore two pluses are there, therefore total number is plus 1. And when consider these two also, as you know, this carbon oxidation number is plus 2, and this carbon oxidation number is plus 3. Therefore the oxidation is take place for organic compound. That means alcohol can oxidize into aldehyde or ketone, or then further it can oxidize into carboxylic acid. Then the final oxidation of the organic compound is carbon dioxide, which has plus 4, the maximum number which carbon can go. As you know, in burning or any highest oxidation reaction take place, organic compound can go to carbon dioxide. These type of reactions you can learn in future lessons of organic compounds. Here, as we know, the good oxidation agent is KMnO4, so potassium dichromate, and finally the burning in air is also some oxidation part. Therefore you can oxidize this kind of compound by adding oxidizing agent, and higher oxidized compound we can reduce by using reducing agent, sodium borohydride and lithium aluminum hydride type of compounds. Dear students, thank you for your attention in this lesson. Up to now we learned about more basic part of organic chemistry. So then in next lessons we can meet with individual hydrocarbons, oxygen contains compounds, nitrogen contains compounds, and individually that type of compounds we can learn everything we have learned in our previous lessons. And see you in next lesson.